I would like to introduce Kam Agahian, who will be presenting Cloud Network Engineering, a closer look. Kam is a member of the program committee and a director of cloud engineering at Oracle. Having traveled from California today to join us on stage, this is Kam's fourth time presenting at NANOG, and it's a pleasure to have you back and speaking. Thank you, Kam.
Awesome, thank you. It's already counting down. So let's get started. Hi everyone, my name is Kam Agahian, and I'm a director of cloud engineering with Oracle. Today I'm here presenting for the fourth time. This is an interesting topic, cloud and network engineering. That's a fairly new career path, and I get a lot of questions on this. This is an interesting topic. I can relate to it. That's one of my really favorite topics. I'm a blogger as well. I write, have books and stuff, and that's one of the most commonly asked questions that people reach out. How do we break into this field? I'm a traditional engineer. I heard a lot of things about cloud network engineering. I want to be one. Or totally brand new person. I'm not even in IT, doing mechanical engineering, aerospace, or something else, but I heard about cloud engineering. How do you make that transition happen? This talk, the presentation we have today, it's an overview of certain things. And I will show you, this presentation actually has three different parts. Quick introduction for people who are not familiar with the world of clouds. The second part, kind of interesting topic. I will show you exactly what it is. And the third part, the amazing part, and that's the technical part of this discussion. So let's just get it started. First things first, let's talk about the cloud for a second. I'm sure most people in the room, they already know what cloud is and what cloud providers do. But for those of you who are new to this field, I can see some younger faces. Let me give you a very simple example. I was interviewing someone, and I actually borrowed this example from that lady. And when you think about this, a couple of hundred years ago, maybe a few hundred years ago, depending on part of the world, people would have ovens at home. Everybody would bake their own bread, right? The second example, interesting one, the water. People would dig to get water. And of course, number of houses, and everybody would have to do this. You know, you can imagine, not always the easiest thing to do. Exact same thing in the area of data centers. I'm sure many people in the room remember that we turn offices into data centers. Sometimes we turn restrooms into data centers. Actually, I did that once, and then we had water leak. People turned basements and, you know, corner rooms and all those things into data centers. Those many data centers, and they would go down, cause a lot of trouble. Well, some people, they could afford it and move into colos and more traditional data centers, depending on the size of business. But eventually, that model would turn you into a person responsible for power, space, and cooling. This is the most basic layer. On top of that, you would have to worry about your server management, what you're going to do with your servers, what you're going to do with the operating system, higher layers, all the way to the application, while that was not even the core of your business. So today, CSPs, or cloud service providers, a handful of them in the United States, they built facilities all around the world, and they offer that service at a wholesale price. It's exactly what it is. So for those of you not familiar with the concept of cloud, that's the quickest way to explain it. Well, if you look at this model, exact same thing I have here in the slide. Now, they worry about the real estate, cooling, space, power, even the servers, and depending on the service, all the way up to managing application. You even, in some cases, don't have to worry about patching your own application, which is pretty cool. So, but who gets that job done? That's exactly what we start talking about this field. But before answering that question, I would like to give you a little background. If you look at this slide, traditional network engineering, right? Between 1990 and 2010, what ruled the roost? There was an interesting field. Many people attracted to it, and we had one of the best training tracks in the world for network engineering compared to software engineering. Coding, still a lot of innovations. Network, we did have multiple different tracks. Go through this program, you're going to be a network engineer. And I know some people started before that. Myself, I started in 96 or 7. But anyways, that's where traditional network engineering kind of started and turned into the field that it is today. Strong overlap with systems engineering. Many of us, especially in the 90s, when we wanted to work as a network engineer, we had to configure Unix servers, Linux servers, all kinds of services, service up and down, even in some cases storages. So it was not pure networking. It was not just router and switch configuration. There's a lot of other things involved. Major employers back then, even today, large enterprises, you know this, service providers and data centers, and even sometimes vendors. Main duties for traditional network engineers: we design networks, we configure those, and sometimes we do regular maintenance depending on hardware and software, sometimes quality of service. Rumor has it, sometimes it doesn't work. And monitoring, capacity planning, some automation. This is more like pre-Python world, and troubleshooting, of course. That whole package was called traditional network engineering. During this time, we had two breakoffs. We had two exits by two groups of people. First group of people, they moved and they started another field, NDE, or network development engineer. People who liked coding. And they wanted to just make some coding with network engineering, do some automation. And that was the first time that group of people, they kind of broke off. The second part, another interesting one, was DevOps. Much stronger automation, coding skills, even as the previous speaker mentioned, people with coding background, familiar with networking, they started DevOps. Traditional operations, but this time with a very strong flavor of coding. Both cases, you can see a strong pattern of preferring build over buy. And in case of DevOps, people would actually create tools to get the job done, not simple scripting and automation. So the group of us who stayed here in this field as traditional network engineers, we experienced 4 technical turbulences, if you will. The SDN, when we talk about SDN, I see smiles in the room, I know, but let's take it for now. SDN was one of those. NFV and VNF, which started virtualizing devices that we had. Denser networking, if you look at containers and containers networking, it's even denser than what you had previously with virtualized networks, and some cloud engineering. So this whole package, again, is what it is today. So we kind of walk from 1998 to today to show you how this field evolved and where we are today. So now we got to this point. I want to talk about cloud network engineering, or field CNE. First of all, major employers hasn't changed a lot, but there are some interesting patterns there too. Enterprises, I will show you why they're hiring people with cloud network engineering expertise. Software service providers, or sometimes we call them ISVs, not much data centers anymore. And of course, vendors, in this case, cloud service providers. In terms of day-to-day activities, just to wrap up the introduction part of this presentation, enterprises, when you work for an enterprise, your whole purpose, the entire mission of a team is to move your workload to the cloud, to make sure it runs and it serves your users. You're not having problems, you built in design you wanted, your cloud footprint is working the way it should. And sometimes people have to configure DR, disaster recovery strategies, some security measures, monitoring, and all those things. At the end of the day, it's all about making sure that your workload works, and works in a good way on the cloud. That's the whole purpose of working as a CNE for an enterprise. ISVs, or software service providers, they will pretty much the same thing, but for multiple customers. So if you are looking at that field, now you are receiving workload from multiple customers for this very popular application of yours that used to work in traditional data centers. Now you care about segmentation strategies. How do I separate out my customers? How do we make sure that customers are contained in their own environment and they can work with the highest throughput or whatever SLA we have with that customer? This is an interesting one. These cloud service providers, they also hire a lot of cloud and network engineers every year. Pre-sales, post-sales, and engineering is 3 major fields. Pre-sales, we meet with customers. Solutions architects, cloud network engineers receive the requirements, they do the basic design, sometimes they do proof of concept for those customers, basic successful deal handed off to post-sales. And post-sales professional services, they complete the design and do the implementation part. Engineering, people who actually build the cloud behind the scene. That's where people care about BGP. That's where people care about fiber. People care about convergence and BFD and timers and all those things. We will get there. So, this is one of my favorite slides. I changed that picture multiple times over the past probably couple of years. That's an amazing demonstration of exactly what cloud network engineering is. It needs a large portfolio of different skill sets. Previously, if you wanted to become a network engineer, we had a very clear definition. Certain things that you had to know to become a network engineer. It was just a pepperoni pizza, right? No matter how many pizza shops in your town, you talk to them, definition of pepperoni pizza is the same. Plus minus 10%, it looks the same, maybe it tastes the same. Cloud network engineering is a combo. If you go to 10 pizza shops, you're going to get 10 different definitions of a combo pizza. That's exactly what cloud network engineering is. Some organizations are very bold when it comes to networking. Some systems, maybe some security, and there's some other expectations as well. My network engineer might understand good deal compliance. We work with FedRAMP customers. I want to make sure that you understand compliance, or HIPAA or something else. And this is exactly what the rest of this presentation is going to be about. We will cover all this. So what is needed? Let's say you like it, and this is what you want to pursue. This is the most basic presentation of cloud engineering. One hand, one side of this, you have the cloud. On the other side, you have my traditional network. And you are in the process of moving your workload. Part of that is gone. Part of that is still in your traditional data centers, and you have some kind of connectivity. 95% of cloud customers, that's exactly what they do. Yeah, there are some customers that are fully migrated to the cloud. They're 100% cloud native customers. But majority of customers, these still follow this model. I'm going to use this model to build the structure of this presentation from now on. First things first, routing. So at this point, what I'm trying to do, I'm trying to build these pillars. If you want to grab this presentation and use it for a job interview in the future, if you want to give advice to people how to become a CNE, or you're working on your skills to transition from a network engineer, traditional one, to a CNE, these slides will help you. And the first pillar I want to talk about is routing. We need routing. Why? Multiple different locations. Inside the cloud, we care about routing, how packets routed from one part of your cloud to another. We care about inter-cloud routing these days. Multi-cloud is next big thing. So you might want to route your traffic from one cloud to another. And most customers, as I mentioned before, they have traditional data centers, and you need to have some kind of routing between the two. How is that done? Here are my expectations, all on one slide. I need two things. Number one, static routing. Number two, BGP. Maybe 60% of your traditional BGP. I'm not going to ask you complex BGP questions. We're not going to go back and forth on details of clusters and how these things work. No. Basic BGP, but probably 50–60% of the contents. We care about the BGP attributes. We do care about different filters, how you manipulate these attributes. All these things are important, and some redistribution as well. BGP cares about convergence. How you make your BGP react faster. How do you make BGP converge faster? How do you retrieve your routing strategy in a faster fashion? All these things are important all on one slide. This is the routing part of this. What's out of scope? IGP. If you know SIS or OSPF or some other IGPs, it's not going to be big here. Good to know. If you want to work for a cloud vendor inside your data centers, you might need this. If you are on a customer side and you want to have connectivity past your border routers, You're going to have to know this, but as a cloud and network engineer, most of the time, we do not care if you know an IGP or not, as long as you understand the basics. So for us, it's kind of out of scope if you want to be a CNE. Here is a sample project, or sample routing project. Customer comes along and they want to have full connectivity between their physical data centers and a cloud. Two options. There's really nothing else. Either you do static or you do BGP routing. And the configuration in many cases remains identical. You care about BGP attributes, you care about communities, and that's pretty basic compared to what we used to have for internet routing. Next pillar. So the first pillar was routing. We built it. We told you about our BGP and static routing. The second one is just as important, encryption. Encryption in transit. For data at rest, the CNE or cloud network engineer probably doesn't care much, but in-transit encryption is extremely important. If you want to go for a CNE job interview, it's going to be one of the questions, for sure. People care about IPsec. How IPsec works. We're talking about the internals of IPsec. Do you know the phases? You can't tell with keys, all the concept. Do you know why IPsec has higher overhead, or is known to have higher overhead? I want to have a NAT gateway. Do you know the concept of NAT traversal? Do you know how we wrap any UDP packets, UDP headers? And VPN, site-to-site VPN using IPsec. So IPsec is a big part of being a cloud network engineer, almost on a daily basis. Next one is MACsec. MACsec is a lighter version, and it helps. And these days, especially since probably a couple of years ago, many cloud providers, they use MACsec as well as IPsec. Very important to know what scenarios IPsec works, what scenario MACsec works. Just to give you a little hint, if you have layer 2 connectivity, then MACsec might be a good option if it's supported by your devices. TLS and SSL are still very important. If you're going for a job interview, just make sure you know the internals of those. So the second pillar here was encryption. We talked about IPsec, MACsec, and TLS as ways to secure your communication between your workload and the rest of the world, in this case, your majority of cases, your data center. Here's a sample project. The previous customer built that network. Let's say they decided to do BGP, and now the question is, I'm connected to the cloud. We had some kind of fiber between the two, or I have this tunnel. How do I implement my encryption strategy? You have multiple different options depending on what you want to do. You want to do a tunnel, you want to do a dedicated connection. Next topic. So let me just review this real quick. We talked about routing. We talked about encryption as a second skill set that everybody needs to know. This is another one, probably a bigger topic, and kind of unique in a sense. I'll tell you why. There are two fields in network engineering. There are two areas and technologies that always fall in a crack. Everybody wants them, and nobody wants them at the same time. One of them is load balancer. The other one is DNS. It's always kind of between the network team and systems team. It is network, it's systems, kind of, but in the world of CNEs or cloud network engineers, there is no doubt here. It is your responsibility to know network load balancers inside out in a cloud and how they work. Some of them, they process lower layers, only layer 3 and layer 4, talking millions of sessions and absolutely high throughput solutions. But in some cases, just like many traditional network load balancers, you want to inspect the packets, like layer 7, let's grab the layer 7 header, HTTP header, and then make a decision. Either way, that's your responsibility. You got to know exactly how they work. Traffic distribution. My load balancer wants to spray traffic across multiple targets or destinations or backend services. How do we do that? Sticky sessions. I want to make sure that my sessions always go to one set of backend services. And that's where you use sticky sessions. TLS and SSL offloading. It's been with us for many years. We all know that terminating hundreds of thousands, even tens of thousands sessions on one backend is not a great idea. No server can do that. Today, network load balancers in a cloud, when I say network load balancer, network and application load balancer, these are different terms, but generally speaking, cloud load balancers, they're able to help you offload that traffic. But some companies, they have some compliance requirements, and they have to have this end-to-end encryption. In those cases, they use end-to-end strategies. Start from the client's browser, go through the load balancer, all the way to the backend service. Do you know how it's configured and how it's done? Some other clients, they want to make sure that on the backend service, you receive the exact same source of your browser. How do we do that? The load balancer sometimes terminates that session and acts as a proxy. You need to be able to change your design to make sure your source IP address is preserved as it goes through this stage to get to the backend services, and of course health check and health checking process. Some advanced scenarios, sandwich designs, you have multiple load balancers, and you have some kind of logic between the two, multi-proxy services. Hybrid architectures, IPv6 is kind of big these days. Containers and container networking using load balancers. Everything you know about servers and VMs, today you need to know the same logic and architecture in terms of containers. And from a load balancer perspective, it's not that difficult. It's actually pretty much the same kind of concept. And of course, troubleshooting and monitoring. So the third pillar here is load balancers. This is something that's kind of unfamiliar when you talk to many network engineers, especially traditional network engineers, familiar with BGPOs, CFISIs, and PLS, but it is part of the CNE world almost every day and every customer. What is out of scope? This is an interesting discussion here. Yes, you're responsible for the load balancers, but you are not responsible for making that call, what services and what servers going to be behind what load balancer, what a strategy, and how you want to manipulate headers, how you want to process those headers. All those calls will be made by systems teams or application teams. And as you can see, hand in hand, shared responsibility. They decide the application side of this. You make sure your cloud load balancer is in good shape, working on processing incoming packets. Sample project, customer has 32 virtual servers and they have a whole bunch of traffic. Let's say they're expecting 1 million sessions coming through network at whatever rate, and they want to process those. Number of load balancers, type of those load balancers, how you want to deal with the headers, all those things. Some of these calls need to be made by application folks, and some of them are part of our responsibilities as CNEs. DNS is another one. Again, kind of interesting, because DNS traditionally, old days, it was part of our responsibility. In the 90s, if you talk to the network engineers in the early 2000s, DNS was part of our responsibilities. We'd always configure DNS servers, responsive for DNS servers, public and private. At some point, early 2000, some other teams in some larger organizations took over DNS as part of systems now, and now, so systems and services, we manage DNS. And in the world of CNE, or cloud network engineering, we're kind of taking it back. It is now part of your responsibility to understand how it works. There are two general strategies and architectures that CNEs work with them every day. Either you have everything in your cloud footprint supports everything in terms of DNS and systems, everything stays there, and that's where you're doing your name resolution. Some other cases, you might have hybrid models, and you want to have name resolution between your on-premises, your traditional data centers, and the cloud. Either way, all major cloud providers support this, and it's a very classic kind of design. Not really tricky, and I want to make sure no one's scared of this. That's going to be a huge responsibility, and it's a very well documented, very well architected solution that everybody with some experience can follow. And we talked about this. You need to know, of course, all different types of records, as we did, and concepts of delegation, DNS hierarchy model, and how that works. And some interesting stuff on this slide. Previously, as part of load balancer management, we were responsible for global load management, meaning globally, if a company had multiple different locations all around the world, let's just say this company had locations in Canada, United States, and Europe, we would use load balancers to make those calls. Where are we sending out traffic? Today, it can be done using that global infrastructure and DNS in a cloud, and it works actually very effectively. You have multiple different factors. You can do this based on latency, geolocation, and an active-passive model for disaster recovery. These are all the things that CNEs design every day. And some advanced architectures, DNS security. I care about my messages. I want to make sure there is some logic there, and it's part of FedRAMP Section 4. And dynamic DNS, I want to make sure my records are registered. V6 again is part of it, and monitoring and reporting. This is another pillar that we built here, and it's a sample project. Again, the customer wants to have name resolution between cloud and a data center, and you are the solution architect. You got to talk to the customer and get all the requirements and make sure you understand the logic, you understand exactly what they have on-prem in terms of the servers, number of zones and records in those zones, how they work, and then understand the cloud side of this. And for resolution, the cloud resources can use the DNS servers on-prem side and vice versa. This is kind of new trend these days, but that's also an amazing one when you think about this. There are many appliances that we use just beyond routers and switches in our traditional data centers. One of the new additions is the whole concept of SD-WAN. If you remember, I'm sure many traditional network engineers in the room, myself included, we all remember those nights and days, you were on call and we would get calls, hey, this site down. Why? Because we had sites with 2 BGP connections. One of them would go down, that was a primary circuit, and sometimes we just did not have any logic to switch traffic over. So people had to manually update their BGP policy to put the traffic on the secondary path. That concept, probably 15 years ago, was developed into something else, and today we have SD-WAN. SD-WAN was a response to that problem and a bunch of other problems, including quality of service. And it does work. Today, as a CNE working with cloud, you can do the exact same thing. You can treat your site, you can treat your cloud footprint as one of your sites, or you can bring your controller, your SD-WAN brain to the cloud. All cloud providers support this, and it's actually a pretty cool design. And it works for a huge number of sites. That's one of the very common models that we see and customers want to do. Another interesting thing in terms of appliances is third-party firewalls. The concept of firewalls in the cloud, it's a little story here. So we started from the very, very basic, that people would build firewalls on the virtual machines when they had designed the foundational layers of their cloud. So you would build the network, on top of that you'd have this VM, and on top of that you'd build the firewall. That model over time turned into something more complex in terms of their architecture, and the latest is cloud providers provide their own firewall service. Depending on your requirements, sometimes it works, sometimes you need something more complex. But the middle layer is a still requirement for many customers. They want to build the exact same firewall that they have on-prem. And for many reasons. Learning curve is one of them. Compliance is another one. We've been using this firewall for 10 years. We have licenses, we have this enterprise agreement, and want to use it. So we need to build the exact same firewall there. And what we offer from a cloud service provider perspective, any cloud service provider without the firewalls is basic, something like the access lists. Beyond that, you need a firewall. I want to do some layer 7 inspection. I want to have IDS and IPS. I want to do some complex NAT scenarios. I want to have some complex policies and treat my different types of packets differently. In those cases, we build firewalls. And that's part of the requirements to be a cloud network engineer. I want to make sure everybody understands this. So it's a little kind of blurred border. Let me highlight this for a second. Part of building a firewall is the process of building a firewall from scratch, getting that image, bringing up the service, making sure it has all the IP addresses you need, it does the routing, it has all the zones you need, the communication happens, management and everything is up. The second part is putting the right policies and all the layer 7 and all the inspection logic on that device. The first part is 100% part of your responsibility as a CNE. The second part, not so much. Although some organizations still want their network engineers to be familiar with firewalls, to be able to use security policies, but at least if you ask me, that takes a security expert. So you need to understand the overall security posture to put best policies together. It's not just a matter of configuring policies. No, you got to understand the bigger picture. So the second part is network firewalls and different kinds of third-party firewalls. We talked about appliances now. We covered SD-WAN appliances and network firewalls. There are other types of appliances as well. But here is a sample project. The customer wants to bring their SD-WAN solution to the cloud. Again, they come to you as a solution architect or cloud network engineer, and you need to design that solution for them. It involves routing, bringing up that firewall instance, making sure that it works and has full connectivity, and traffic passes through, and then you hand that solution off to someone else who's responsible for the policies. Automation, that's an interesting topic. Well, some CNE positions, they require you to understand automation. Good news is, this automation here is scripting and it's not traditional coding. So for a job interview, if you're preparing or if you're planning to transition to that position in the future, we are not talking about complex software engineering questions. We're talking about scripting. Reason is APIs. There are very rich and strong APIs, great libraries out there. All cloud providers, all you need to know is to understand the right KPIs. From my perspective, trust me, shouldn't really take more than 5 days of training for any network engineer to be able to make those API calls. Again, you are not creating tools, you're not creating complex programs. All you're doing is you're making sure that your logic, the overall flow works, and you're calling the right APIs to automate construction of your cloud, and then later, sometimes to monitor those. Again, hundreds of APIs out there to help you manage your cloud environment. So do not be afraid to give it a try. It's actually pretty straightforward. Some other services, not as big as the previous ones that we talked about. We talked about routing, that's a big one. We talked about encryption, again, not a big one. Network load balancers and DNS, these are all big ones. And appliances, of course. But these are all smaller services that as a CNE you need to know to be successful in that position and to be successful when you're interviewing for those roles. Network address translation, NAT is one. You need to understand how it works, source NAT and destination NAT, the difference between the two. Concept of DHCP, NTP, CDN, CSP firewalls. So some cloud providers, they have their own firewalls, and designing for those firewalls also key, very important, and billing. Many network engineers or CNEs say, even architects, well, billing is not my responsibility, it's someone else's money. No. One of the big requirements is to make sure your solution is not burning cash. There are different ways to do different architectures, and in order to support the customer or your employer, you got to be very careful. There might be different ways, and there might be different ways to come up with ideas to save money. We always, when we work for a customer, we always make sure that that part is taken care of and the customer doesn't have to pay for services they're not using. So billing is important. One of the interesting constructs that some service providers, some cloud providers use and could be very expensive, and many people do not realize, is NAT. NAT is considered an expensive service when you're designing a cloud solution. Or different cloud providers have different egress and ingress charges for your traffic. These are all your responsibilities to understand what's going out of a network, how much is coming back into the network, and how much we're paying for that. Soft skills, that's one of my kind of favorite slides. The reason I put this slide here is many of us, when we work as cloud network engineer, we end up in positions where they're customer facing. And those positions are very popular, especially on the pre-sale side. Several reasons. One of them, to be very honest with everyone, it's an 8-to-5 job. The other one is you get to work on different projects. If you have kind of personality, you want to work on 4 projects a day, and tomorrow I'm going to work on 4 other projects. I want to work on this customer's network for 7 days and then switch on a totally different network. That's a customer-facing job for the most part. Some skill sets listed here, and those things are not difficult if you do not have those. Every now and then people contact me, actually one of them to write on my cell phone this morning. And it was an interesting comment. Person said, oh, I don't think I'm much of a salesman. We're not asking anybody to be a salesperson. Sales is done by someone else, not by the CNE. Let me just be very clear. As a solution architect, as a CNE cloud network architect, you're not responsible for closing a deal. You're not negotiating, you're not offering, or you're not accepting any offer. On the customer side, you will review the best. You will build the best for your employer. On the cloud provider side, you work with the rest of the team to make sure the best solution is put in place. So taking feedback, being able to stay calm, being able to articulate what you mean, being able to present effectively to the customer, being a good listener, these are all key skill sets. And we welcome women and minorities. This is a field I've been working a while, and you can see people from all walks of life, and this is really amazing culture. Interesting next 2 slides. We're kind of wrapping this up, but the future trends of cloud network engineering. That's a very fair question that many people ask. Okay, look, this is really hot today, but how about 4 years from now? How about 7 years from now? How about 10 years from now? You know, next 7 years is not hard to predict. In fact, many deals are signed today, and many businesses are making huge investments. They have this 7-year vision. So 7 is kind of near future. In that time period, what's going to happen to this field and cloud in general? I kind of listed here some key items. We're going to have more construct flexibility. What that means is, when we started this, let's go to 10 years ago, right? We had very simple network constructs. Let's take the NAT gateway. A NAT gateway was actually a path gateway. Port address translation. Simple path gateway. Multiple private IPs and one public IP, traffic in, traffic out, full translation, source NAT, no destination NAT. Now we're seeing a trend that is changing over time. Now we're adding more NAT features to those, and we're supporting more and more IP addresses, especially on the public side now. That's interesting. It's turning into a real NAT gateway. Same as routing. Routing gateways. Any service provider 5 years ago, 6 years ago, very simple. Today, it's actually a virtual router. It does a lot of things that you used to do on virtual routers. Firewall architectures used to be very simple. Today, you can do a lot of complex architectures, pretty much just like your data centers in cloud. And traditional networking, when we started this trend, when we started cloud engineering, everybody thought, like, okay, it's going to be an abstraction. We're not going to have everything here. For example, we're not going to have layer 2. We're not going to have all these complex fields. But over time, we realized we're kind of walking in a direction of building those. So that's where we need you as network engineers. That's where you're welcome to join. Why? Because people realized it's not just drag and drop. It takes some network engineering skill sets. And that's what makes that transition so quick. And you're always welcome to join, because we can't just grab people off the street and train them for 5 days through some videos, as previously people thought, and turn them into cloud network engineers. No, your background is very much needed. And the second point is kind of obvious, but I still want to reiterate that we're going to have higher throughput components. That's a never-ending process. From 1 gig to 10, 10 to 100, 100 to higher throughputs. It's going to go even higher rates. This is an interesting one, especially the second point. If you look at the cloud providers past 10 years, a very limited number of regions, or in other words, loosely speaking, limited number of data centers in the US East and US West. If you're in the middle, well, problems. Today, the number of regions is increasing among all service providers. And it is possible to build one right next to your facility and give you access to one. So that concept, that paradigm is kind of changing. Another interesting trend is this one, and that's kind of the most important trend, multi-cloud. Several years ago, people wanted to stay in one cloud, everything right there, secure. We're going to go through one set of training, and we're done. We know how things work. Today, multi-cloud is important. And cloud providers, some of them, creating connections between themselves. And there are partners out there. You can work with them and connect through multiple different clouds. You might want to have a split workload. You might want to keep your application on one side and put your database on another side. And then you care about latency, you care about a bunch of other factors. But at the end of the day, you're getting kind of best of both worlds. You have the best application, and you have the best database throughput on the side. So expanding job markets across all different verticals. If you're in finance, if you are even non-network, non-IT, even something like medical doctors, the field is expanding so quickly that everybody's welcome to join. At the bottom, I put a link to a blog post I have, and many people contact me because of that blog post. It's actually a log project that I do update very often, and it shows exactly how to break into this field. You don't have to start from scratch. It starts from very scratch. It's talking like you know nothing and you want to be a cloud network engineer or a cloud architect. But if you have some background and you want to join that process, you can just join after tier 2 or tier 3. Please do not be shy. Please do reach out. Sometimes when I spend time past midnight, I'm still responding questions. Random people, total strangers, but all great questions. And at the end of the day, it's collective success. If you were successful, we're all successful. And it's not about any particular trend or vendor or this field or that field. Pretty much there's room for everyone. So that was my last slide. And I think I'm done with this, but I would love to take questions if someone wants to ask questions. Otherwise, we can end this, please.
Any questions from the audience? We do have one online question here. I might pull that up for you. This is from Justin Morse. How do you recommend that an engineer learns a given cloud without paying large bills for a service for a lab?
That is a great question. Let me just rephrase that question. So many people who want to learn network engineering in a cloud and become a cloud network engineer, they have to have a lab. Previously, with traditional networking, we had to build physical labs, or you had to rent labs. Either way, we had to pay. It was not a free service. Same cases here, right? Exact same case applies to this. Almost all cloud service providers, they have some free tier that you could use for some services, and beyond that, you pay. That's one thing. The second thing is, many services, as far as I know, it's very hard to put a percentage on it, but majority of services, unless you put serious load on them, you're not going to be billed and you're not going to have to pay a lot. Why? Because there's two factors. There is a timing factor, duration of time, how long you're using the service for, and how much traffic you're putting through that service. Majority of services. And for a lab, most likely you're not going to be using that lab for more than a few hours. At least I can't work more than 4 or 5 hours just testing. And you're not going to have any amount of serious traffic. So the bill should not be that big. Something kind of trivial but still important, do not forget to terminate your lab. Just stop your services before you go to bed. Otherwise, you have to pay. It's pay as you go. So 2 things here. Number 1, look for free tier services. And number 2, you're not going to have serious load. Just make sure you're not running the lab for a long time. Otherwise, you're going to end up with a big bill. Other than that, should not be a big deal. Hope I answered that question. Just this one, or?
Yeah, just that one right
Oh yeah,
there.
we covered that.
Any other questions from the audience or online? Excellent.
Okay.
And thank you,
Cool.
Cam. Round of
I
applause
appreciate it.
for Cam.
Thank you so much, everyone.